All right, you've multiplied radical expressions and simplified them. Our last operation we're going to do with radical expressions is we're going to add and subtract them. Adding and subtracting, just like with variables, has a different set of rules. So when you add and subtract radical expressions, the radicands, the numbers inside the radicals, need to be the same. If you think about variables in like terms, it's kind of along the same lines. You can't add or subtract two radicands, two radicals that are different numbers. Just like you can't add or subtract two variables that are different. You can't add x's to y's. Once you have the same radicands, you just combine the coefficients using addition or subtraction, depending on what the problem is. So if you have a square root of x plus b square root of x, the radicals are the same. So you just add the coefficients, a plus b. If it's a squared of x minus b squared of x, square roots are the same. You just subtract the coefficients, a minus b. It's really not that difficult once you get your radicals the same. The problem is the radicands, are not always the same. If they're not the same, you're going to have to simplify them. Maybe one of them, maybe both of them, to get the same radicand so you can combine them. So if it's not the same radicand, the not like term radicand, you might have to do a little bit of simplifying to be able to combine them. So let's see how it looks. Got three easy ones for you to start because all three of them have common radicals, like terms. All right, so the first set, square root of 2 minus 3 square roots of 2. Well, remember, there's a coefficient here of 1. So it's just 1 minus 3 gives me negative 2 times the square root of 2. There's my answer. Notice my radicand inside the radical didn't change because I'm not multiplying them. I'm treating them like a variable, like it was like terms. If you did 3x plus 2x, you would make it 5xx. You don't change the variable. You don't change what's in the radical when you're adding or subtracting. Negative 10 square roots of 3 plus 7 square roots of 3. Well, combine your coefficients because you have like terms. So you've got negative 3 square roots of 3. Don't change what's inside that radical when you're adding and subtracting. Keep it the same. It's not a multiplication problem now. And negative 6 radical 5 minus 4 radical 5. Combine those coefficients, and you get negative 10 radical 5. When your radicals are already like terms, it's pretty easy. Well, what if they're not like terms? Well, you have to do a little simplifying. The nice thing is you know what you're trying to simplify to if you're not sure what the numbers break down to. So this 8 radical 3, well, I got to get 147 to become like terms with radical 3. So even if you don't know what factors of 147 are that could be perfect squares, you know you're trying to get a 3. So I'm going to do 147 by breaking it down by dividing by 3 and its factor pair. And the factor pair of 3 is 49. Look at that, there's my perfect square. So now 49 comes out of the radical as a 7, multiplies the 6 that's already there. So now that's a minus 42 radical 3. And my first one doesn't change because that was already in simplest form, 8 radical 3. And then is 8 minus 42 for my coefficients. So negative 34 radical 3. All right, same thing here. Square root of 6 cannot break down, so I'm going to leave it as it is. And that means that I know I'm trying to make this into a radical 6 to become a like term. Well, that's okay anyway, because 150 is pretty easy. 150 was 25 times 6. And there I got my 6 to get my like term. So 25 is the perfect square, comes out. Square root of 25 is 5. Times the 9 that's already there is 45. Radical 6. I've got myself some like term radicals now. So remember, this is negative 1 radical 6. And 45 radical 6. Combine your coefficients. You get 44. Radical 6. Don't change that radical. I'm going to say that multiple times because somebody's going to make that mistake. Well, what if you have to simplify both radicals? 150 No, not a perfect square, and I see some perfect square in it. 96. That's a little harder, so I'm going to pick the one that's easier to work with. 150. 150 I know is 25 times 6. And that 25 is going to come out and become 5 times the negative 3 is negative 15. Radical 6. And the reason that is really helpful is because now I know I'm trying to make a radical 6. So even if I wasn't sure how to break down 96, I know I'm trying to make a 6. So I'm going to take this 96 and break it down into a 6 times whatever it is. In this case, that whatever it is a perfect square pair, 16. So 16's square root is 4 times the negative 6 that's already there is negative 24 radical 6. So once you've broken one radical down, you know you're trying to make a like term of the second one, so try to use that and see if it helps you. Combine those coefficients, negative 15 minus 24 is negative 39 radical 6. And last but not least, 75 and 108. Well, 108 is not easy to break down necessarily. 75 is much easier because there's that 25 again. I love those 25 multiples because they're easy to see usually. 25 times 3. So now take that 25 out, and it becomes 5 radical 3 minus. Now I know I'm trying to get a 3 in here. So I'm going to break that down into a 3 times whatever its factor pair is. And 3 goes into 108 36 times, and look at that. 36, there's my perfect square to factor out. So 36, square root out, is 6, times the 10 that's there is 60, times radical 3. And then add those, or in this case, subtract those coefficients, 5 minus 60, negative 55, radical 3. Remember, don't change the radical when you add or subtract. Always looking to find that like term radical, combine those coefficients, you got yourself a final answer. Have fun.